Alright guys, I am going to show you two methods to subtract using whole numbers and mixed fractions. I apologize for the glare, but hopefully this will still come through to you. Okay. One method is called the regrouping method, and then the second one that I'll show you is the improper fraction method. With the regrouping, just like we do with subtracting and a number that requires regrouping process to occur, it's on a base 10 foundation. When we regroup using time as our measurement unit, we use 60 because 60 minutes is equivalent to an hour, 60 seconds is equal to 1 minute. And with fractions, it's a little unique because I tell the students that the most important part of a fraction is your denominator. It tells you the whole group size. So with this, I am going to use the 3 in my denominator from the 2/3 fraction as my group size. So in order to make a whole group, it has to be 3/3 to make 1. So if that is the case, I can take this 3 and make it as 2, because 1 less than 3 is 2. And then what happened to that 1 that I took away from this 3? Well, if I look at my denominator, I can say that 3/3 represents another whole. So 1, 3/3, which is 1, plus this 2 will still give you the same value as what I started with, which was 3. Now I can subtract 1 and 2/3 from it. Well, whole number must be subtracted with the whole number. So therefore, I'm going to use a different color, and I'll use blue. I have 2 minus this 1, which is, and I'll underline so I can show you the answer, which is 1. Now I have 3/3, which comes right here from this 3/3, minus 2/3. Well, with the rules for fraction, and especially for subtracting and adding, we must have a common denominator. Well, it is a common denominator, it's the same. So therefore, I'm going to keep it, and I only have to work with the numerator now. 3 minus the 2, which is 1. So my final answer to this problem that originally started with 3 minus 1 and 2/3 becomes 1 and 1/3. And you can check this by saying 1 and 1/3, my answer, plus what I subtracted, which was 1 and 2/3. Well, whole numbers being added together, 1 plus 1 is 2. And I'll underline it so you see where I came from. And then I have, I'm going to put to the side, 1/3 plus 2/3, which is equal to 3/3, and 3/3 represents 1. So I have come back over here and add it, and therefore it still gives me 3, and that's what I started with. I'm going to switch over to the other side and use the improper fraction method. Well, I know that this is a mixed fraction and this is a whole number. Whole numbers can always be placed over 1. So now I'm going to put this 3/1 minus, well, to convert a mixed fraction to an improper fraction, I tell the kids make it look like a clock. Start from the denominator and work yourself to the left, back to the right. And we're going to use the process of multiplication and addition. So therefore, 3 times 1, which is 3, plus the 2, which is 5. So now I have 5 over what I started with, which was 3. Now, you have 3 over 1 minus 5 thirds. The rule is you cannot subtract a fraction when the denominators are different. You must make it a common denominator. So what do I need to do to this 1 to make it look like this, 3? I must multiply it by 3. If I multiply it by 3 to the denominator, I must do the exact same thing to the numerator times 3 to keep it in balance. Why is that? Because if I really look at this, 3 being multiplied by the denominator, 3 being multiplied by my numerator, this in essence is saying 3 over 1 is being multiplied by 3 over 3, which is still the value of 1. This here is 1. So anything times 1 is itself. So it didn't change the value. It just made it equivalent. And that's all it did. So now I come over here. 3 times 3, which is 9, over 3 minus 5 over 3. Now, since I have the same denominator as 3 in this example, I know that I'm going to keep it, and that gives me the green light to say I can now subtract the numerators. 9 minus the 5, which is 4. Well, you're like, wait a second, it still doesn't look like 1 and 1/3. In reality, it really is, because I'm going to show you a picture model first. My denominator says I'm going to have 3 parts to it, and I'm going to shade in 4. Well, I'm going to start shading this now. Here's 1, 2, 3, and I don't have any more to shade. But I need to shade up to the quantity of 4. So I'm going to recreate my picture. There it is. And I'm going to break it into 3 parts because it says my denominator tells me it's the quantity of 3 to make up a whole. And now I'm going to shade in. I've already shaded in 3, but I need to get to 4. Here's my 4. Now this becomes 3 over 3, which is equal to 1 whole. And now in this fraction I have 1/3. And if I add these together, I get 1 and 1/3. And that's why this improper fraction looks like this. Or you could have done this through long division, because this fraction bar really means I'm going to do the division process. So it's saying 3 divides into 4. Well, we know that it can go into 1 time. There it is, long division. Here's 1. My remainder becomes my numerator. And my divisor becomes my denominator. So there. You can do it through division when you get an improper fraction. You can do a picture model to represent what is really happening. And then you can do the regrouping method, as long as you know how to put the importance to the denominator. In this example, again, my denominator tells me my group size, and that's what I did. I took 1 away from this 3, which is now 2. What happened to the one that I took away from there? That was 3 over 3. And anything over itself becomes 1. And therefore, it works this way. Hope this helps.